Welcome to the MSU Denver video walkthrough of the elementary Accuplacer. In today's video, we're going to be going over the section on fractions. And within that, we're basically going to be doing a couple things: multiplying fractions, dividing fractions, adding and subtracting fractions. And if you take a look at the top of page 10 in the MSU Denver Elementary Accuplacer Study Guide, you can see they have a very brief description on each of those things, and I'll be going into those a little bit more in depth. But if you're looking at that as you follow along, it should make a little bit of sense. So let's get started, and I'm going to start with multiplying fractions. So if we have a fraction, let's say 3 over 2, and I multiply that by, say, 5 over 7, then all you do when you're multiplying fractions is you simply multiply across the top and then multiply across the bottom. And so our answer would be 3 times 5 is 15 over 2 times 7 is 14. Our answer is 15 over 14. Now it's important that we reduce. In this case we can't reduce, and we'll get to some examples where we can reduce, but it's important that if I say I have 5 over 10, that's not my final answer. My final answer would actually be I can reduce that to 1 over 2. And we'll get into how we do that a little bit later, but you must reduce your fraction at the end. A couple other notes is that even though we can say, oh, well, 1 over 2, I know that that's 0.5. 0.5 is not an answer, or it's not an answer that you're going to see on this test because we don't have calculators, so there are no decimals anywhere on this test. So the final answer for this problem, if it were 5 over 10, it would be 1 over 2. As long as you reduce it, that's all you got to worry about. Now in our answer, you can see that we came up with 15 over 14. And that is the final answer that we're going to see. Some people might say, well, that's the same thing as 1 and 1/14. And that's true, and you may see that in places, but on this test you're never going to see that. It's always going to be left as an improper fraction, which is what this is right here. This right here is called a mixed fraction. And you're not going to see, ooh, I can't even spell, okay, I'm a mathematician, not an English major. Mixed fraction, and what we have here is an improper fraction. And that's how you're going to see it on the answer key on this test. Both are correct, but you're not going to see the mixed fraction. You're going to see an improper fraction. And that's all you have to do when multiplying fractions. You just simply multiply across the top, multiply across the bottom. So moving on. So moving on from fractions, let's go to the dividing fractions. Actually, real quick, I want to do one more example. If I have something like, say, 5, and I multiply that by, say, 2 over 3, there's two ways you can do this. You can turn any whole number into a fraction by simply putting it over 1. And you'll need to do that a lot, but if any number divided by 1 is just itself, so we're not really doing anything to it. And so then when I have 5 over 1, I can multiply that now by 2 over 3. And it's the exact same thing as we have above, so I just multiply across the top, which is 10, and then I multiply across the bottom, which is 3. 1 times 3 is 3. And it's 10 over 3. And I can't reduce that, I can't simplify that, and I leave it as an improper fraction the way it is. So our answer for this particular problem would be 10 over 3. However, you don't have to take that full step right there into changing it into 5 over 1. If you can just realize that you take the whole number and then you just multiply it by the numerator, then we simply see 5 times 2 is 10, and that becomes our numerator, and then our denominator stays the same. Because essentially what we're doing with our denominator is multiplying it by 1. And so we have 10 over 3, which is the answer that we got down below. Whatever makes you feel comfortable, that's what you want to do. All right, so, and you're going to see that quite a bit, and so you want to be comfortable multiplying a whole number by a fraction. You can either turn it into a fraction, or you can just leave it the way it is and multiply it across. Now we're going to go into the dividing fractions. Excuse me. So dividing fractions. Let's say I have 2 over 3 again, and I divide that by, say, 5 over, let's say, 4. This bar right here simply means division. So another way you might see this exact same problem is written out like this: 2 divided by 3, so 2 2/3, and then I put the division bar, and then I put 5 over These are the exact same problem. Okay? All right, so now let's work this out. What you want to do is you want to take the numerator, and I want to write that out. So I'm going to write 2 over 3. And then I'm going to put a dot, right? And dot in math means multiplication. So I copy the top number, dot, and then I flip the bottom number. So we're dealing with 5 over 4. I'm going to flip it. I'm going to write 4 over 5. So whether I do it using this form over here on the left, I would copy the top down and I flip the bottom and I put a dot. Or the top, all you have to do is pretty much rewrite it, right? 2 over 3, and then replace the division sign with a dot, and then flip the second number. So this would be 5 over 4, and you get the same outcome. And then once we're at this point, we have 2 over 3 multiplied by 4 over 5. Well, now it's just like multiplying fractions, which we just saw was very easy. We just multiply across the top, multiply across the bottom. Our answer becomes 8 over 3 times 5 is 15. 8 over 15 can't be reduced, so that's our final answer. And that's it. I'm going to do one more with a whole number, just like we did with the multiplying fractions. If I have, say, 3, and then I divide that by, say, 2 over 4, I can either turn it into a fraction or I can leave it as 3, but I still want to copy the top. So I'm going to copy it. I'm going to put it over 1, because any number divided by 1 is just itself. And then I'm going to put a dot just like we did above, and then I'm going to flip the bottom, 4 over 2. Now, there's a couple things that you can do here. You can simply multiply across the top, right? 3 times 4 is 12. Multiply across the bottom, 1 times 2 is 2. And then we could say, well, you're never going to see decimal, so usually when we have a fraction, it is what it is. We want to reduce. But here we can see that 2 goes into 12 an even number of times, so we're actually going to get an answer of 6 out, and you do want to do that math. If it's not a whole number that's going to come out of it, we just leave it as a fraction. We reduce it, but we leave it as a fraction. The other way I could do this is I could say, well, I could, and you're going to see this a couple times, not with whole numbers all the time, but even with fractions, I can reduce over here, and that's not so bad. Or I can reduce it before I multiply, right? I can say, well, this is the same thing as 3 over 1 multiplied by, well, 2 over 4. I can reduce that. I can say that's 2, and that's 1, right? So this becomes times 2 over 1. Or simply 3 times 2 is 6 over 1, or just 6. So we get the same answer. In this case, 12 divided by 2 is pretty easy to see that it's 6. But in a lot of cases, reducing is not that easy, and so it behooves us to kind of go this way first and see if we can reduce it before we multiply, because it's a lot easier to reduce fractions before we multiply than after, and we'll see examples of that. But before we go into any more examples of that, let's go over adding and subtracting fractions. So when we are adding and subtracting fractions, I'm going to put down an example. I'm going to say 3 over 5 minus 7 over, 8. Adding and subtracting is pretty much the same thing, but we just changed the sign there. And I'll walk through at the end what an addition of fractions would look like. But there's actually an extra step for subtracting fractions, so I'm going to go through that example first. The biggest thing for adding and subtracting fractions is to make sure that we have a common denominator. How do we do that? Well, the easiest way is to multiply the denominators by each other, right? So in this case, I would multiply this 5 by 8, and I'll multiply this 8 by 5. Now, whatever I do to the denominator, I have to do to the numerator. So over here on the left, I'm going to multiply the top by 8, and over here on the right, I'm going to multiply the top by 5. Why do we do that? Well, if we look now, I'm essentially multiplying the left by 8 over 8. What is 8 divided by 8? Well, 8 divided by 8 is simply 1. And as we discussed before, multiplying or dividing anything by 1 doesn't change it. It stays the same. So although I'm going to change the number, I'm not really changing the fraction. I'm kind of unreducing it, if you will. And then over here on the right, I'm doing the same thing. I'm multiplying it by 5 over 5, which is just 1, and anything multiplied by 1 is itself. All right, so now let's see what that comes out to be. 8 times 3 is 24. over 8 times 5 is 40, minus 7 times 5 is 35, over 8 times 5 is 40. Well, now we have the same denominator, and it's called a common denominator. And that's the easiest way to get that, multiplying the numbers, the two denominators by each other. When you have something, and we won't do this for a while, but when you have something like even, I don't know, x plus 1, 1 over x plus 1 plus, I don't know, 3x over x squared plus 2, right? You can, I don't know any other way to do it, just to multiply them by each other. There may be a common denominator, at least common denominator, that you could get with numbers before actually multiplying the denominators. But in the sense, once you get to problems like this one over here, you really don't want to worry about that. You just want to multiply the two by each other, the two denominators by each other. I'm going to erase this real quick so I can show you something else. If I have something like 1/3 plus 2 over 9, well, then I can kind of see that the least common denominator between the two would be actually 9. I can multiply this left by 3 and get a 9, and then I don't have to do anything to the right. So if you can see a least common denominator, then just use that, because that would save us some reducing later. Now, if you don't do that, if instead you do multiply them by each other, so I multiply this by 9 and this by 3, and then I multiply the top of each one by the same, you would get the same answer, it just wouldn't be reduced, and so you'd have to reduce it later. But even if you find a least common denominator, you still may have to reduce later. So I just say just multiply them by each other and save yourself some time, unless you can easily see it like this one over here. But even if you don't easily see it and it's easy and you do it by multiplying the denominators by each other, you're still going to get the correct answer. You're just going to have to make sure you reduce. And you always have to make sure you reduce anyway. So it's good practice to get into. So back to our original problem, we have 24 over 40 minus 35 over 40. So what we do now is, now that we have a common denominator, we can simply combine the two over that common denominator. And so I have 24 minus, and then I'm going to put in parentheses 35, all over 40. And the reason I did that, it wouldn't make a difference in this scenario. It would just be 25 minus 30. We can take away the parentheses. But if, for instance, I had on the top there, when you get into variables and stuff, if I had something like, instead of 35, if I had 24 minus, let's say, it was x plus 1 over 40, right? So now it would look like this, 24 minus x plus 1 all over 40. It's important that we put the parentheses because we need to distribute that negative, right? So this would actually become 24 minus x minus 1 when we distribute that negative 1, essentially right here, all over 40. And that's very different than saying 24 minus x plus 1, right? Which a lot of people use. And if we look at the distributive properties on page 7, then we can see that distributing that negative 1 is very important. If it's a plus, if all of this was a plus instead, well, distributing a plus sign, if this was a plus, right, that means that I would distribute this plus 1 to this, and then the plus 1 to that, and it would become x plus 24 plus x plus 1, and it wouldn't be any different if I just didn't have the parentheses there. But when we have a minus, when we subtract fractions, it's very important to put that parentheses there. I'm going to erase this problem now. I'm going to erase this extra stuff up here so we don't get confused. But it becomes very important to put parentheses there later on when we have larger mathematical problems. So it behooves us to get used to it. Down in our original problem, the parentheses don't really mean anything because there's just a 35 in there. But so now let's finish off this problem. 24 minus, in parentheses, is 35. 24 minus 35 would be negative 11 over 40. Since 11 is a prime number, we know it can't reduce. So negative 11 over 40 is our final answer. And just a quick note here, that negative 11 over 40 is the exact same thing as 11 over negative 40. I can move that negative sign around. And that's the exact same thing as negative out in front, 11 over 40. And this last form is usually what you'll see it as. But those are all identical. All right, if this were indeed addition instead, then we have that addition sign still there. This would still be an addition sign there. We don't do anything different. This would be an addition sign here, and then it would be 24 plus 35 all over 40, which would be, let's see here, 59 over 40. And I don't believe that can be reduced either. That's pretty much it with fractions as we'll see them in this section. One other thing that I can see in one of the example problems, and we'll go over this more when we get to exponents, which will be actually in the next section, but it has something like a fraction, so let's say 2 over 3, and then it squares it. And on page 7, as we looked into very simplistic, is it page 7? I don't even know what page I'm talking about anymore. No, page 7 is the multiplication table. I'm talking about page 4 when I was speaking about distribution and distributing the negative and this exponent that I'm talking about. The beginning of page 4, which you all should have looked at for some very basic rules. The second half of page 4 and page 5 we're going over as they come up, but the first half of page 4 you should all definitely look over. But that talks about what an exponent is, right? And we're just basically, we're taking the number inside here and we're multiplying it by itself this number of times, so 2 times in this case. But I don't really want to think about what 2/3 is, what 2/3 squared is. You know, I mean, I could write it out as 2 over 3 times 2 over 3, and that's actually very simple. But I can also break this down into something that looks like this: 2 squared over 3 squared. And again, once you have 2/3 and you're just squaring it, I mean that's actually not so bad as I wrote down. You just multiply across the top, multiply across the bottom. But when the numbers change and when the exponent changes, it does get a little more difficult, and it usually will be much easier just to do it in this way over here. And so I simply do 2 squared is 4 over 3 squared is 9, and so our answer is 4/9. And if we do it this way, you know, in the center here, we'd get the same answer. But again, once those numbers start changing and the exponents start changing, it becomes much more difficult to do it like this. So I would recommend against that and just separating it like it is there. And that, my friends, is all the explanation I'm going to do with fractions. And now we will get into the actual example problems. I'm going to do just half of them. I'm going to do the even half. I encourage you to do the odd half on your own. And if you have any questions, please come into the Tutoring Center and ask them. Okay, so I'm going to go through these examples fairly quickly. We should all have the order of operations down, and we should be pretty comfortable with it. And if you don't, I encourage you to go back to the previous video and work on those example problems. But so with as far as the order of operations go, I'm going to move fairly quickly. And so let's get started. So number 2 is what I'm going to start off with. I'm going to do all the even problems. Number 2 is -3 over 5 multiplied by -15 over 9. And there's 2 ways to do this. We can simply say -3 times -15 is a positive 45. 5 times 9 is also a positive 45. And 45 over 45, we reduce that. That's simply 1. The other way to do that, and in this case, it's very simple. You know, 45 divided by 45 is 1. There's not much reducing going on. But like I said earlier, it behooves us to look at how we can reduce this before we actually multiply it out. And the question becomes, can I make the bottom, anything on the bottom, look like anything on the top? I have a 5 and a 9 on the bottom. I have a -3 and a -15 on the top. Well, I can change this -15 into a 5. I want a positive 5 so that I can cancel it out. I want to, and then I would have to have a -3. And now that I have a 5 on the bottom and a 5 on the top, I can cancel it out. Now, how do I change the 9 to look like? I have 2 -3s on the top. Well, if If I change the 9, I need a negative 3. I want to cancel out negative 3. So what does the other number have to be? Well, it's a positive 9, so the other number also has to be a negative 3. Negative 3 times negative 3 is a positive 9. Well, this negative 3 can cancel out with this negative 3. This negative 3 can cancel out with this negative 3. And essentially, everything that I'm crossing out becomes 1s. So now what I have essentially is 1 times 1 times 1 over 1 times 1 times 1. And that's just equal to 1 over 1, which is equal to 1. Again, in this scenario, it's actually 45 over 45. That's pretty easy to see that it's just 1. But when it comes to something like, 27 over 81, it might be a little bit harder for us to see that that's actually just 1/3. But we'll see more of those in future examples. All right, so number 4, put a little box around this one. I'm not sure of everything that you guys are seeing. Let me try to scoot that down a little bit. All right, number 4. Number 4 says we have 1/3, and we're dividing that by 1 over 9. So what do? Well, we change into a multiplication. How do we do that? We say that's 1 over 3. We copy that down. We change the division sign with a dot, meaning multiplication. And then we have the 9 over 1. Again, this becomes 9 over 3, which is simply 3. But if I can see that that 9 can become 3 times 3, I can cancel out this 3 and this 3. These become essentially 1. And I have 1 times 3 is 3 over 1 times 1 is 1. So 3 over 1, or just 3. Again, if you do it the regular way and you just say 9 over 3, it's fairly easy to see that 9 over 3 reduces to a whole number of 3. All right, now I'm going to move. These will get a little bit tougher as we go on. I'm going to move on to number 6. Number 6 says we have 2/5. I want to multiply that by 6, which the parentheses is telling us that word. It's an implied multiplication there. And then divide all of that by 3 over 4. And again, if you watch the previous videos, I usually say that just pretend that there's a parentheses on the top and a parentheses on the bottom of the fraction. Why is because we want to essentially make sure we do all the top first before we worry about dividing by anything. So let's work on the top. There's 2 ways to do the top. We can say that that's 6 times 2 over 5, or we can say it's 6 over 1 times 2 over 5. But whatever you do, it becomes 6 times 2 over 5 times 1, and that's simply 12 over 5. That does not reduce. And then we divide that by 3 over 4. All right, so now we have 2 fractions dividing by each other, or 1 fraction divided by the other, I should say. And so this becomes 12 over 5. Then we put the dot, copy dot, and then we flip the bottom number, so it becomes 4 over 3. Now again, there's 2 ways to do this. We can multiply it out first, and then we can try reducing later. Or I can see that I want to make some of the numbers on the bottom look like some of the numbers on the top. How can I do that? Well, I have a 3 right here, and I can change this 12 into a 3 times 4. Now I can cross this 3 out and cross this 3 out, and those become 1. And now it becomes 1 times 4 times 4. So just 4 times 4 is 16. And 5 times 1 is 5. So it becomes 5 over 16. If we choose to do it the other way, we would get 12 times 4 is 48 over 5 times 3 is 15. And while that's the correct answer, it's not reduced. And so we would need to reduce it, and we'd have to say, well, this is essentially 16 times 3, and this is 5 times 3. So we pull out a 3 of each one, and it becomes 16 over 5. But to me, it makes it much easier to do that over here than to kind of see. It's hard for a lot of people, including myself, to see that 48 is actually 16 times 3. And if you can see that, great. But it does become even harder than that. Like, what about 17 times 3, 18 times 3, 19 times 3? What are those? 57 is 19 times 3. And so it's much easier to do that in the previous section where we have smaller numbers. Plus, it makes multiplying also easier. Instead of doing 12 times 4, I'm just doing 4 times 4. All right, so our answer for that is 16 over 5. If we look in the back, it should be that, and in fact, it is. All right, so let's move on to number 8. I'm going to scoot that up. All right, number 8. Number 8 says we have 5 over 6 parentheses negative 9 over 10, and then we're going to multiply that by negative 4 over 5. Again, there's two ways to do this. You can multiply it all out and then reduce, or I'm going to first look for things that I can reduce. Well, I already have a 5 up here and a 5 down here, so I don't have to do anything. I can see those. Great. I can just cancel those out and those become 1. I also have, let's see, this can be 2 times 3, and this could be 5 times 2. Let's see here. This can be negative 2 times 2. Okay, well now I have a positive 2 here and a positive 2 here, and those become 1. Down here I have a negative, up here I have a negative 2, and down here I have a negative, a positive 2. So I cannot cross out a negative 2 and a positive 2. I can't do it. What I can do is I can say, well, instead of 5 times 2, I can say that's negative 5 times negative 2. Negative 5 times negative 2 is also 10. Now I have a negative 2 and a negative 2, and I can cancel those out. So I'm going to rewrite my problem because there's a lot of crossed out marks over here. But essentially, on the top I have negative 9, and then on the bottom I have, let's see, a 3 right here times a negative 5, and then the rest are just 1. Okay. So the negative 9 on top, there's nothing to do, so I'm going to leave that there. 3 times a negative 5 is negative 15. The two negatives cancel out. This becomes, oh, you know what? Let's see, let's keep going. 9 over 15. And I can say, well, I can pull a 3 out of each one of those. All right? And this would become 3, and this would become 5, so the answer becomes 3 over 5. And that was easier to do. I got most of them out, but I actually missed something over here. Over here we have a negative 9, and down here we have a positive 3. I can actually change this negative 9 to negative 3 times 3. Now I have a positive 3 and a positive 3 I can cancel out. This positive 3 over here would go away, and up here it would just be a negative 3. Again, if we do this reduction, and some things you can't see, if you don't see everything like I didn't see, everything that you do see, everything that you cancel out does make it easier. The more you cancel out, the easier it becomes, but if you don't see everything, that's okay. We didn't see everything, we got 9 over 15. Once we get 9 over 15, you still have to understand that's not reduced. So always look to see, even if you think you caught everything like I did, make sure it's completely reduced. I can easily see that 9 over 15 is not reduced, and so I reduce that. The nice thing about the test is that it's multiple choice. I really don't like multiple choice for math problems, but one nice thing about it is that if I have 9 over 15 as my answer, I'm not going to see that as an option. I'm going to see 3/5, and I'm going to see 3 wrong answers as an option. And so it's nice if I did the math correctly, and I know I did the math correctly, I said, well, I got 9 over 15, and then I don't see that on one of my options, I can ask myself, well, can I turn 9 over 15 into something, into one of the 4 options? And indeed I can. I would see 3 over 5 because I know that this is the correct answer if we check in the back. That's not always the case. You want to make sure you reduce it all the way because on any other given test you might not have that option, and if you just put 9 over 15 down, they might also trick you, and they might also put that as one of the options, and that would be incorrect. If both 9 over 15 and 3 over 5 are options on multiple choice, 3 over 5 is correct. 9 over 15 is not. 9 over 15 is not reduced. All right. Or you can just, catch the mistake like I did. Like I did not, but if you catch them all, then it's actually much, much, much easier. Because if you catch all of the simple reductions that you can do in the first part of the problem, you shouldn't have any more reducing to do. Again, it's always good to check because you might miss something, but Ideally, you catch everything before you multiply across the top, multiply across the bottom. All right, let's go on to number 10. Put a little squiggly there so we know where the problem starts. Number 10 says, oh, this is a lot of stuff. Okay, we have negative 5 over 3. And I encourage you to do these problems on your own before I walk through them, but if not, that's okay. We have 3 over 5 plus 1 over 2, and then more parentheses. We have 3 over 4 and divided by 1 over 2, and that parentheses, and the last set of parentheses. Okay. Again, per the order of operations, we're going to go into the innermost one. You guys should be comfortable with this. And the innermost one says 3 over 4 divided by 1 over 2. That's the same thing as 3 over 4 times 2 over 1. I'm going to cancel that out. I'm going to make that a 2. So the innermost, so I'm going to rewrite my problem. I like to, if it's a big problem with a lot of steps like this, I like to rewrite it a lot. So now I have negative 5 over 3. This is 3 over 5 plus 1 over 2. And in parentheses I have, let's see, this is a 1. 3 times 1 is 3. 2 times 1 is 2, so 3 over 2. All right. Now again, per the order of operations, we're going to do set next. This becomes negative 5 over 3, parentheses 3 over 5, plus, and then we do this multiplication here, straight across the top, straight across the bottom, and we get 3 over 4. All right, we actually haven't, in the set of examples I've been doing, we haven't, I don't believe, yeah, we haven't actually added any fractions. So this is good. Now we're going to add these fractions together. In the fractions, in the other fractions, if you've been following along with the odd problems, you actually have gone through this already, starting with problem number 1. But I'm going to rewrite that over here. That's going to be negative 5 over 3 plus, and okay, so what do I have to do over here? Let's see. I'm going to actually rewrite the whole problem first. 3 over 5 plus 3 over 4. And I have to find a common denominator, and to do that, I'm going to multiply this one by 4. I got to multiply the top by 4. I multiply this one by 5. I got to multiply the top by 5. So what do I get? Negative 5 over 3 times. I have 3 times 4 is 12, plus 3 times 5 is 15 over 5 times 4 is 20. That becomes, excuse me, negative 5 over 3 times 27 over 20. All right, so from here, again, you can multiply across the top, multiply across the bottom, get an answer and reduce. Or you can reduce here first. I have a 3 on the bottom. I want to get rid of it. I am going to make this a 9 times 3. Those 3's cancel out, so I have 9 on top. I have a negative 5 on the top. I'm going to cancel this 20 on the bottom. And I need a negative 5, so I have to put a negative 5 there. Again, you can't cancel out a 5 or a negative 5 with the opposite sign. So I have to have a negative 5. Well, to get a negative 5 with a positive 20 result, I have to have a negative 4. The negative 5's cancel out, and essentially what I have is 9 on top. Again, these all become 1. And a negative 4 on the bottom, which is the same thing as negative 9 over 4. I can move the negative around. If we look in the back, that is our final answer. Let me just check to make sure. Negative 9 over 4, that's our final answer. That is the last problem, last even problem that I'm going to perform in this section. I encourage you guys to, you guys and gals, to do all the odd problems. And again, if you have any more questions, feel free to leave them in the comments below or come into the tutoring center and ask.